Alright guys, welcome back. We're going to look at step functions today. This is section 8.1.3. So, a step function is a special kind of graph, special kind of piecewise function. Let me adjust this here. Alright, it's a special kind of piecewise function, a function composed of parts of two or more functions. A step function has a graph that is a series of line segments that look like a set of steps. Just like the ones here, we go from one step to the next step to the next step to the next step. Step functions are used to model everyday situations where there are abrupt changes in the output of the function. The endpoints of the segments on step functions are either open circles, indicating that this point is not part of the function, or filled in circles, indicating that this point is part of the function. The graph at the right models a situation in which tour bus companies have buses that can hold up to 20 passengers with 5 available buses. So on our x-axis we have the number of passengers. On our y-axis we have the number of buses being used. Let's break down this graph a little bit. So in this scenario, we have 1, 2, 3, 4, 5 steps, each representing the buses. You'll notice that these lines start with an open circle and end with a closed circle on all of the lines. Thinking about where you want that open and closed circle is going to be an important part of making step functions. A lot of times that's the hardest part, is figuring out whether the open circle should be in the front or the back. We need an open and closed circle so that it remains a function and we pass the vertical line test. Remember that the vertical line test for a function says that when you draw a vertical line, it can only go through one point on the function. If both of these were closed, then we would have two values for 20 here. We would have one bus and two buses. Right now, the open circle tells us that this is not a value for 20 and that 1 is the value for 20. So again, let's look at this graph. So this says that if there are 0 passengers, we will need 0 buses. There should probably be a closed circle right there at the bottom, because if you have no passengers, then you don't need any buses. But as soon as you have 1 passenger, you're going to need a bus. So if we go to 1, we go up here, we get to 1 bus. If we need 10 passengers, if we have 10 passengers, we still just need 1 bus. If we need 19 passengers, if we have 19 passengers, we need 1 bus. If we have 20 passengers, we need 1 bus. Now we've completely filled that bus. So if we have 21 passengers, we're going to need 2 buses. So we jump from needing 1 bus to needing 2 buses when we go from 20 to 21 passengers. The 20th passenger is still on the first bus, so the closed circle goes with the first bus. 21st passenger is now on the second bus. So if you're on the 21st through the 40th passenger, you're on the second bus. As soon as we go from 40 to 41 passengers, now we need a third bus. So that jump happens every 20 passengers. We need an additional bus. I've given you a little example to think about here. I want you to sketch a graph of the following scenario using a step function. Think about where you should have an open circle and where you should have a closed circle. WeHaul charges $20 a day plus $2 each mile driven to rent a moving van. We want to sketch a graph of that. I have the setup for the graph right here at the bottom. This is the cost to rent a WeHaul for 1 day. Well, we can think about this. We know that it's going to start off $20. That's the bare minimum you're going to pay. You have to pay them $20 to get it off the lot. Then you're going to do $2 per mile driven in addition to that $20. So we're going to have some markers down here on our x-axis that will be the number of miles that we drove that day. And I think we can get the idea of how the function is going to work and what it's going to look like if you just go out for the first 5 miles. So think about what's going to happen, how much it's going to cost you to drive each mile, what those step functions are going to look like as you go through there. All right, guys, we'll talk about it in class. Have a good one.